Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at 9.2, Analyzing Rational Functions. So some key ideas, determining asymptotes and points of discontinuity. So the graph of a rational function may have an asymptote, a point of discontinuity, or both. So to establish these important characteristics of a graph, we begin by factoring the numerator and denominator fully. So your first step with all of these questions is factor first. The first thing that happens, asymptotes, that comes from no common factors within our numerator and our denominator. So if the numerator and denominator do not have a common factor, then the function has an asymptote. The vertical asymptotes are identified by non-permissible values of the function. So non-permissible values basically meaning that is where our denominator is equal to 0. So if I had something like x plus 2 over x plus 3, well, my denominator is what gives us those vertical asymptotes. So if I set that equal to 0, I find that at x is equal to negative 3, that is where my vertical asymptote exists. Then we have something called horizontal asymptote. So a horizontal asymptote can be found by examining the degree of the numerator and the degree of the denominator. So if the degree of the numerator is less than the degree of the denominator, that means we have a horizontal asymptote at y is equal to 0. That would come from something if I have like a 2x plus 1 over an x squared plus 3. The degree of my denominator is a degree of 2, whereas the degree of my numerator is a degree of 1. So when we have something like that, our horizontal asymptotes always happen at y is equal to 0. If our numerator degree is equal to our denominator degree, then we have a horizontal asymptote at y is equal to the leading coefficient over the leading coefficient. What that might look like is 2x subtract 4 over 4x plus 7. Well, my leading coefficient comes from the term that has the highest power, so in this case our x, and the number that's attached to it. So in this case, it would be 2 over 4 or 1/2. So then we have a horizontal asymptote at y is equal to 1/2. And then our last one is if our numerator is greater than our denominator degree, something like x squared subtract 2 over 2x plus 1. We've got a squared over a linear term. This is no horizontal asymptote. So points of discontinuity, this is where we have at least one common factor. So if the numerator and denominator have at least one common factor, there is at least one point of discontinuity in the graph. So to find these, we equate the common factors. So if I was to have a function that looks something like x plus 2 over x plus 3, which is all over x plus 2 times x plus 1. Well, right here, we've got a common factor across our numerator and denominator. To figure out where these points happen, to figure out the x-coordinate, we set our common factor equal to 0. So negative 2 is the x-coordinate of that. So then we would substitute the x value into the simplified expression. Well, our simplified expression would be y is equal to x plus 3 over x plus 1. And we would plug our x-coordinate into that. So this would become y is equal to negative 2 plus 3 over negative 2 plus 1. So y is equal to 1 over negative 1, or just negative 1. And so this means the coordinate of our point would be negative 2, negative 1. And so what that looks like is if we've got a function, there would be a hole or a point of discontinuity, and then our function would continue on. Both asymptotes and points of discontinuity. So if a rational expression remains after removing the common factors, just like in that last example it did, there may be both a point of discontinuity and asymptotes. So for example, in this one, we would also have a vertical asymptote at x is equal to negative 1. So example 1, determine whether the following functions have any points of discontinuity, vertical asymptotes, or horizontal asymptotes. So first thing, if we're checking for discontinuity, there's no common factors in our factored expression, so there's no points of discontinuity. Points of discontinuity can also be called holes, so there's no holes in our function. Our vertical asymptote, that happens where our denominator goes to 0, so this would be at x is equal to -4. You need to tell me, in this case when we're talking horizontal and vertical asymptotes, if the equation of the asymptote is either an x is equal to or a y is equal to, just because those are both possible options. In this case, to check for our horizontal asymptote, we want to check to see the degree. Well, we both have a degree of 1 in our numerator and denominator, and so that means we're going to check our leading coefficients. Well, so leading coefficient over leading coefficient. In this case, our leading coefficient is 1 over 1, so it's y is equal to 1. If we look at b, so our first step is we need to factor. So something like f of x is equal to, so multiplies to be 6, adds to be -5. That's going to be x subtract 3, x subtract 2 over x subtract 3. Well, if we look here, we've got common factors. So if we've got common factors, that means we have a point of discontinuity. So our discontinuity or our hole happens at 0 is equal to x subtract 3, which is our common factor. So x is equal to 3. And then we want to figure out, so f of 3 is in our reduced function, which is just x subtract 2, would be 3 subtract 2. So that's at 1. So our point of discontinuity is at 3, 1. Because when we simplified, we were left with, there is no vertical asymptotes because we don't have any x's in our denominator, and we have no horizontal asymptotes as well. That function, x subtract 2, is just a line. Okay, example C. So first step again is factor. So y is equal to x subtract 4 times x plus 3 over x subtract 4, x subtract 1. We have a common factor, so our discontinuity happens at x is equal to 4. Our reduced function, or our final function we would graph, would be x plus 3 over x subtract 1. So if we put 4 into that function, so an f of 4 is equal to 4 plus 3 over 4 subtract 1, which is 7 over 3. So this point, our hole in our graph, is at 4 and 7 over 3. Our vertical asymptote comes from where our denominator is equal to 0, so that would be at x is equal to 1. And our horizontal asymptote, we have equivalent powers, so that comes from our leading coefficients. So our horizontal asymptote is at y is equal to, well, 1 over 1 or just 1. Our next graph, so f of x is equal to x subtract 5, x plus 1 over x subtract 3, x subtract 2. We have no common factors, so no discontinuities or no holes. We have vertical asymptotes where our denominator goes 0, so x is equal to 3, x is equal to 2. And we have equivalent powers. I definitely just noticed our notes don't match this example, so that's fun. But this one, equivalent powers, so that's going to be a horizontal asymptote at 1 over 1, because there's leading coefficients of 1. All right. So example 2, find the x and y intercepts, the horizontal and vertical asymptotes, if any. With our horizontal asymptotes, we also need to check to see if they cross. Because our graphs, it gets more into calculus, but basically at this level of our understanding, it's we can cross horizontal asymptotes at small values of x. So we might cross at things like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We might even cross at 14, but as we go out to 7,388,484, we might not be able to cross our horizontal asymptote at that point. We also are going to check for points of discontinuity if they exist, and use a sign analysis to determine whether y is positive or negative, and then graph our function. Okay, so our first step, we're going to check for discontinuities. So in this case, there's no common factors, so no holes, no points of discontinuity. Vertical asymptotes happen where our denominator goes to 0, so this would be at x is equal to 2. Our horizontal asymptotes, because we have equal powers, happen at our leading coefficient, happen at y is equal to 1. Our y-intercept, remember that happens where x is equal to 0. So y is equal to 0 plus 3 over 0 subtract 2. Y is equal to negative 3 over 2. So this point would be 0 and negative 3 over 2. We also have x-intercepts. Those happen where y is equal to 0. So 0 is equal to x plus 3 over x subtract 2. Multiply both sides by x subtract 2. 0 is equal to x plus 3. X is equal to negative 3. So this happens at negative 3, 0. So here we found x and y intercepts. We've checked for horizontal. We want to check to see if we cross our horizontal asymptotes. So in order to check to see if we cross our horizontal asymptotes, that is where we said our horizontal asymptote was at y is equal to 1. So if 1 is equal to our function, well, if I multiply both sides by x subtract 2, I get x subtract 2 is equal to x plus 3, and I get negative 2 is equal to 3. Well, that's not true, so then because that's not true, therefore, no, it doesn't cross. We've checked horizontal, we've found our vertical, we've checked for points of discontinuity. All that's left is we need to do a sign analysis. So sign analysis, we take our factors of our function, and so we've got x plus 3 and x subtract 2. Well, x plus 3 goes to 0 at negative 3, and at positive 2 is where our x subtract 2 goes to 0. Well, so if I pick a value that's less than negative 3, so something like negative 4. If I put negative 4 into x plus 3, that gives me a negative number. If I pick zeros in between there, if I put 0 into, so 0 plus 3 gives me a positive number. And if I put something like 4 in, 4 plus 3 gives me a positive number. And our other ones, if I put negative 4, subtract 2 would be a negative number, 0 subtract 2 is a negative number, and 4 subtract 2 is a positive number. So overall, we are positive, negative, positive. And so now we're going to use this information to graph our graph. So to start, I'm going to put in our asymptotes. So we have a horizontal asymptote at y is equal to 1. We have a vertical asymptote at x is equal to 2. We have a x-intercept of 0 and negative a half. I'm sorry, that's our y-intercept. Yeah, so 0 and negative 3 over 2. We've also got an x-intercept of negative 3 and 0. And other things. It does not cross. We don't have points of discontinuity. So now we're going to use our sign analysis. So it's saying where x's are less than negative 3, they are positive. Where our x's are, our y's, where our x's are less than negative 3, our y's are positive. Where our x's are between negative 3 and 2, our y's are negative, and so what that looks like to start, so here's our -3 piece. Maybe I'll do that with red. So that means our y's are positive, negative, and they're going to come along our asymptotes. So these we're not doing a super accurate sketch, we're just doing a generalized sketch. And then our last one, they're positive. Well, so that might look something, they're going to come along our asymptotes like this. General sketch. So B, we've got x squared subtract 5x plus 6 over x subtract 2. First step is we are going to factor. So we have f of x is equal to, this would be x subtract 2, x subtract 3 over x subtract 2. Well, we've got common factors, so we are left with f of x is equal to x subtract 3. Well, common factors tell us we have points of discontinuity. That happens where our common factor goes to 0, so at x is equal to 2. To figure out what that actual point is, f of 2 is equal to 2 subtract 3. That's at -1, so our point is 2, -1. And we're left with a line. So we have vertical asymptotes, none. Horizontal asymptotes, none. If we wanted to figure out our x and y intercept, we could. Our y-intercept, this is a line, would be at -3, would be at 0, -3. If we wanted to solve and figure out where our x-intercept was, that would be at 0 is equal to x subtract 3, so at 3. And if we wanted our domain, so if I was to look at this graph, so things we have, we've got a hole at 2, -1. We've got an x-intercept at 3, and we've got a y-intercept at -3. We've also got a slope of 1, so if I wanted to graph more points, I could. So we'd put our line through there using our ruler, we'd stop at our hole, and then we would continue all the way along on our graph. So our domain for this graph would be x cannot equal, well, x can't be -2 or +2, but other than that, x can be anything. And our range is y cannot equal -1, but other than that, y can be anything. So f of x is equal to x squared plus 3x subtract 4 over x squared plus 2x subtract 8. So first step, we're going to factor. So f of x is equal to x plus 4 x subtract 1 over x plus 4 x subtract 2. We've got a common factor, so that is a point of discontinuity at x is equal to -4. So f of -4 is equal to -4 subtract 1 over -4 subtract 2. So -5 over -6, or +5/6. So our point is -4 and 5/6. Our function we're then left with is x subtract 1 over x subtract 2. We've got a vertical asymptote at x is equal to 2. We've got a horizontal asymptote at y is equal to 1. We want to check, does it cross? So 1 is equal to x subtract 1 over x subtract 2. X subtract 2 is equal to x subtract 1. And we get -2 is equal to -1. Well, that's not true, so therefore, no, it does not cross. Our x-intercept happens where y is equal to 0. So if I'm simplifying, I left with, well, I guess I'll start this. Multiply by x subtract 2. Those reduce to 1, and we get 0 is equal to x subtract 1, or 1 is equal to our x. So 1, 0 is our x-intercept. Our y-intercept happens where x is equal to 0, so y is equal to 0, subtract 1 over 0, subtract 2. So that's positive 1/2. So on our graph, let's start filling in information. We've got a vertical asymptote at x is equal to 2. We've got a horizontal asymptote at y is equal to 1. We've got a point of discontinuity at -4 and 5/6, so not quite 1. So maybe right there. We've got x-intercepts and y-intercepts, so an x-intercept of 1, 0, and a y-intercept of, it was 1/2. And then we also need to do a sign analysis. So our factors were x subtract 1 over and x subtract 2. Those happen at 1 and 2. Negative, positive, positive, negative, negative, positive. So overall, where our x's are greater than 1, our function is positive. After that, our y's are negative. So we skip over the whole and we come along our asymptotes. And on the other side, then, it is always positive. It's going to go along our asymptotes. So 2x squared plus 6x over x squared plus 2x subtract 8. So we have f of x is equal to, well, we'll take out a common factor of 2x, and we are left with x plus 3. Over, if we factor, this would be x plus 4, x subtract 2. Well, we have no common factors, therefore no points of discontinuity. Within here, we've also got vertical asymptotes at x is equal to -4 and x is equal to 2. Horizontal asymptotes, remember that happens, we have common powers or like powers. In this case, our leading coefficient is 2 over 1, so this would be at y is equal to 2. So then we want to see, does it cross? So if it crosses, it would be at 2. So 2 is equal to, I'm going to go back up to our fully, I guess, distributed expression over x squared plus 2x subtract 8. Well, if I multiply both sides by x squared subtract 2x, or plus 2x subtract 8, I get 2x squared plus 4x subtract 16 is equal to 2x squared plus 6x. Well, my 2x squareds cancel out, and I'm left with -16 is equal to 2x, divide by 2, and I get -8 is equal to x. So in this case, yes, it does cross. And it crosses at -8 and 2. Our x-intercepts happen in our numerator, so 0 is equal to 2x times x plus 3. So set each piece equal to 0, so 0 is equal to 2x and 0 is equal to x plus 3. So x is equal to 0 and x is equal to -3. So those points are 0, 0 and -3, 0. We've also got y-intercepts, and that happens at f of 0, so 2 times 0 times 0 plus 3. Well, if we're multiplying by 0, that means our f of 0 is equal to 0. So 0, 0. And then last but not least, we are going to do a sign analysis with our whole function. So we are going to have our 2 is a factor, x is a factor, x plus 3 is a factor, x plus 4, x subtract 2. So within here, well, we go to 0 at 0. We've got -3 we've got -4, and we've got +2. Your spacing on these doesn't really matter. I'm just setting it up as just where things would change at. Well, 2 is always positive. X is negative, negative, positive, positive, negative, negative, positive, 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 negative, positive, 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 negative, 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 positive. So overall, we've got positives, a negative, a positive, a negative, and a positive. So using this, we can graph our function. So to start, let's put in our asymptotes. So we have a horizontal asymptote at x is equal to -4. We have, a vertical one, a vertical at x is equal to 2, a horizontal at y is equal to 2. We've got no discontinuities, but we found out that it crosses our horizontal asymptote at -8, 2. So we cross our asymptote. We've got 0, 0 as a point. We've got -3, 0. And that was all the points we found. So from there, we can use our sign analysis. So we are positive and then negative. At -4, we are positive the whole way. So it crosses our asymptote. So we're going to be positive the whole way. Between -3 and 0, we are negative, and then we are positive. And then we're back to negative. So we are negative, we cross and become positive, we cross and we're back to negative. And then our last one, we are positive the whole way.